Hello guys, we are back with our next lecture. In this lecture, let us go through the next topic. So we are continuing evolution of a computers, guys. So in this lecture, we'll be discussing the next three types. So in the last lecture, we discussed the concept of a punch cards. Then we discussed batch operating system. After that, we discussed spooling, right? Yes. So in this lecture, we'll be discussing about multiprogramming, multitasking, multiprocessing. So these are the three terminologies which most of the students will always think that what exactly do they mean, right? Yes, because these terms are commonly heard. If you are a CSE student, you might have heard these terminologies multiple times, and in some kind of vivas in your college, faculty will always try to confuse you by asking these questions, right? Yes. So let us try to understand these things really carefully in a proper way, guys. Okay. Yes. So let us start first with the multi-programming, guys. Okay. So first of all, I'll be explaining you the concept, like how exactly they work. Then we'll be moving on to the theory, guys. Guys, I do understand the evolution of this operating system. This concepts might be really boring for most of the students because they are completely theoretical topics. And the only thing is we will never see these applications, right? Yes, because these are outdated. And if you want to watch them, like if you want to see punch cards how they are used, just to type in Google, guys, you will be getting many pictures. And if you want to see a real time, like how exactly it is worked, I think I have already watched a video on this by IBM, guys. So once type in YouTube, you might find a video from IBM. Okay. Yes. Okay, so let us start our discussion. So multi-programming. So what exactly do they mean by the word, guys? So multi-programming, right? Yes. So why I am breaking this terminology is because these things will be confusing, right? Yes. So what exactly multi-programming means is, so assume that we are having a CPU, guys. Okay. So assume that you are having three jobs to perform. Okay, so assume that these are the three jobs, right? Yes, and you want to perform these three jobs. Okay, and we are going to have only a single CPU, guys. Okay, so in multi-programming, we are going to have multiple programs which we want to run with a single CPU. Remember, with a single CPU. Okay, and one more most important thing that you should remember is, if your system is having a single CPU at any moment of time, okay, the CPU will be running only one program, guys. Remember it, guys. So even your system nowadays, even now advanced systems which you are using, every system, if it is having a single processor, it might be i3 7th generation, 9th generation, any kind of generation, if it is only a single processor, it will be able to run only one application. It will look for us that we are downloading a movie, we are watching a movie and all those things at a time, but in the back end, the CPU will work only on one item at a moment of time. But the context switches will be ultra fast, like they will be done in nanoseconds. Like we can't even identify that particular second, right? Time, right? It is into 10 power minus 9 or milliseconds into 10 power 6. So that is the main reason why we assume that the system is doing multiple things in parallel, but indirectly the CPU is only one and it will do only one process at a time, guys. Please remember this statement, guys, because most students always think that a multi-programming or multi-tasking system will be able to run multiple programs at once. Okay, remember it. Okay, yes. So assume that job 1 is running in the CPU, and suddenly assume that job 1 wants some input hardware, input output device. Okay, so at that time what CPU will do is, CPU will send that job A outside. It will say that please go outside, please get your input output and join back. So in that way the CPU will say, and CPU will take the next job, because there are three jobs waiting for CPU, right? Like if A is running, B and C are waiting. So then it will take B and it will start running B, and assume that now B wants to do something else. So it will send that B outside, it will take C. So in that way, so once someone is idle or someone wants something, the CPU will swap them, guys. So this is swapping, like changing this thing, is nothing called as a context switching, guys. Context switching. Okay, yes, I'll be giving you the theoretical definitions also, don't worry. Okay, yes. So once if there is any kind of output or if there is any other requirement, you will use the secondary disk. So if the particular file is not fitting in this particular storage, you will take from here. So in that way, based on things. Okay, yes. So now you got some idea, right? So in multi-programming, what is the thing, guys? So there will be only one processor but multiple programs, and we will use the concept of context switching to switch in between programs. Got it? Yes. So now let us start the theoretical discussion. Okay. Yes. So I wrote it clearly. CPU can run only one process at a time. Okay. And to be clear, I am saying job A, job B, job C, right? So these are individually called as a processes, guys. Okay. Okay. Yes. I'll be discussing the difference between process and program also in our future lectures. So don't worry, guys. Okay. Because I don't want to give everything in a single video, right? Yes. Okay. So let us continue. So now we are clear with that. Okay. So when a job or process A started, okay, and a job A wants the result of job B. So here I am creating some dependency, guys. So assume that a job A task is done, but job A wants to print the data of job B. So at that time, first job B should be done, right? So at this time, we are going to swap job A and job B outside. So basically, job A will move from CPU to outside and job B will come inside. So now job B will be running and job A will be waiting for job B to complete, right? Yes. So this concept of swapping is nothing but a context switching, guys. Got it? Yes. The main idea of a multi-programming operating system is it keeps several jobs in main memory simultaneously. So if you observe here, there are total 3 jobs. So in real time in our systems, there will be some thousands or hundreds of jobs waiting, guys. Right? Yes. Okay. Yes. So initially, all jobs are on the disk in the job pool, all awaiting for this main memory. So basically the origin of these jobs will be from the main memories, from the secondary memory, guys. So from here, once they get a slot in this main memory, they will come here. Again, they will wait here for CPU. So this is a step-by-step process. You can assume in that way. Okay. Yes. So now let us go through some advantages and disadvantages, guys. So the major advantage about this is, so did you notice any time that CPU is idle, guys? No, right? So that is the reason why it is going to have high and very good efficiency and utilization, guys. Okay. Similarly, lesser response time and wait time or turnaround time. Guys, I'll be discussing about these terminologies later on, guys. So for now, you can keep this particular option aside. Okay. And this third thing says that several processes share the CPU time. Okay. So basically what it is going exactly, guys. So several processes share CPU time. So indirectly this CPU is being used by job A for 30 seconds, by job B for 45 seconds, by job C for 90 seconds. So in this way they are going to share the particular thing, right? Yes. And assume that job A wants something in between. So it will go out and it will give chance to the next one. So in that way this process will be done, right? Yes. Okay. And when it comes to disadvantage, complex schedule handling. So basically here someone should be there, right? So other than CPU, someone should take care about who should come inside, who should go outside and all those things. So that is a small disadvantage when it comes to here. And similarly, complex memory management. So again, we need to have someone to take care from the memory from here to main memory. So that transfers and everything should be taken care by someone. So these are the 2 disadvantages when it comes to multi-programming operating system. So basically for these also we are having some modules, guys. Okay. Yes. So where memory management will be taken care by paging and there are various methods, right? Yes. Okay. So now you got some basic idea about multi-programming, right? Yes. So now let us go through multitasking, guys. So most of the students will be thinking that multitasking and multi-programming are same. Yes, you are correct, but up to some extent, guys. So what exactly multitasking says is a multitasking, or it is also called as a time sharing operating system, guys. So what exactly we do is, so this is the real time, you can say, guys. So assume that I am using a computer in which I am searching something in the internet and I am writing that data into the Excel sheet and I am drawing something and I am playing a video. I am listening to some audio book or some video, you can assume in that way. Okay. Yes. So indirectly all these processes should run continuously, right? So I cannot say that once the browser task is done, then go to Excel. Once Excel is done, then go to Paint. Once all these things are done, go to Media Player. Like that I cannot say, right? Because that is the thing with when it comes to multi-programming. Until some issue comes, we are not going to swap them, right? Yes. So that is the reason why this multitasking came into play. So what exactly we do in multitasking is, here we divide time for each and every task, guys. Okay. So assume that your system is working really fast. So at that time, your system, each process, you will give 1 millisecond for it. So this process will run for 1 millisecond, this process will run for 1 millisecond, this process will run for 1 millisecond, this process will run for 1 millisecond. Cycle again repeats. So 1 millisecond, 1. In this way, it will repeat until all the processes are slowly being completed, right? Yes. So this is the concept of multitasking, and this is the real thing which applies in our systems, which shows us that they are running in parallel, but this is the hidden secret which is going on, guys. Got it? Yes. So now you are getting the idea about this, how exactly our operating system is also working, right? So that is the reason why I told this subject is an interesting subject, guys. The thing is, if you understand the things, they will give you really interest in this, right? Yes. So in modern operating systems, we are able to play an MP3 music player, edit a document in Word, surf a Google Chrome, all running at the same time by context switching. So that is the reason why I am using these terminologies, because indirectly what it is doing, this is giving 1 second for this, 1 second for this. So means indirectly, previously this guy is in the CPU. So now this guy will be pushed out and this guy will be brought in. So what is this process, sir? Context switching. Got it? Yes. The illusion of parallelism is achieved. So basically that is the illusion, guys. Okay. Yes. So for multitasking to take place, multiprogramming should exist. So basically multitasking depends on multiprogramming, right? Yes. So that is the present of multiple programs ready for execution, and secondly the concept of a time sharing. So basically here what we are doing, we are exactly sharing the time. So this is the concept of a multitasking, guys. So now you are getting the idea, right? Yes. Okay, so now I think everyone is 100% clear with the multi-programming and multitasking, right? Yes. So in both of them, we are going to have only a single processor, guys. Okay. So now when it comes to multi-processing, okay, so I think everyone is listening the word processor in this, right? Yes, you are absolutely correct, guys. So in multi-processing, we are going to have multiple processors, guys. Got it? Yes. So this is the concept of multi-processing. So here we are going to have multiple processors, so which means indirectly here you can run multiple programs parallelly, guys. Okay. So now your question will be, do anyone use these systems? The answer is the data centers like Google, like multiple servers, they all use this multiprocessing only, guys. So even if you want, you can buy even motherboards with these kind of things, guys. So a motherboard which is having two processor slots where you can keep two different processors. So those two same processors. So those kind of things are also available, guys. Okay. Yes. So using that CPU, you can run two different systems. So you can connect them to two different monitors, and those both can run two different tasks at the same speed. So there will be no lags or anything, right? Yes. Okay. So now let us go through the theory, and even these are of two types also, we'll be discussing them. So don't worry. Okay. Yes. So it refers to the use of two or more processing units, that is a CPU, with a single computer system with the common buses, memory and IO. Got it? Yes. So here each processor can take a task and complete it, which makes parallelism possible. The things which they use are for data centers, servers, AI applications, machine processing, and image processing, and many things. Okay. Yes. So this is a small structure. If you want to identify it, it will be really easy, right? Yes. Okay. So now let us go through the two different types. So the first type is symmetric multiprocessing, and the second type is asymmetric multiprocessing. So what does the first word say, guys? Symmetric means they are indirectly same or controlled by themselves, right? Yes. So in a symmetric multiprocessing, a single operating system instance control two or more identical processors connected to a single shared memory. Yes, commonly all processors run the same operating system and communicate with each other, right? Yes. So here what exactly happens is we are going to have multiple processors, and they will communicate among themselves, and they will share the work, guys. So basically assume that there is a project which you got. So assume that this is a team of 4 members and a project has been given. So they among themselves will divide that particular thing, right? So that is the exact thing which is done by this symmetric multiprocessing also. So here they are going to divide the work based on their wishes, and they will assign their work and they will start working on it. Got it? Yes. So that is the concept of a symmetric multiprocessing. So here everyone is equal. When it comes to asymmetric, so here one guy will be the king, guys. So he will inform you to do this, you to do this, you to do this. So in this way, he is going to take care like who should do what. So it will be taken care by a single guy. So that is the reason why asymmetric is a type of a master slave architecture, guys. So basically the one who is giving orders will be the master, and the ones who are just blindly working on whatever job they got are slaves, right? Yes. So like one particular CPU responds to all hardware interrupts, where all other works in the system makes their distribution equally. So basically they are going to distribute themselves, and one will be the king, and he is going to control everyone. So controlling is the only task for that particular processor. Got it? Yes. So the major advantages with respect to multiprocessing is it increases the throughput at low cost. So basically if you observe here, so here we are buying only processors. We are not going to buy the whole motherboards, right? Yes, so I know that motherboards will not be that much cost when compared to processors, but it is some kind of cost reduction, right? Yes, so that is what we want. So it is a low cost and it increases reliability, because assume that on a particular day this particular processor has been damaged, so these three guys will complete the work, right? So there is no problem. So that is an advantage when it comes to multiprocessing, guys. Okay, so assume that in your system, in your home, there is a system. So if that system had an issue with the CPU of the processor, you need to change it, right? So it will not on, it will not even turn on, right? Yes. And similarly, low battery consumption and lesser heat generation, as we are having only a single system, inside that only we are having all these processors, so the power consumption will also be lesser, right? Yes. And the only disadvantages is it is really complex to build these kind of things, guys. So that is the reason why every one of us will not have servers in our home, right? Yes, we always rent our servers from somewhere, right? Yes. So that is the main reason. Okay. And similarly, large main memory is required. So basically, if you are trying to run these many processors, so indirectly, if your system is having 8 GB RAM and you want to have 8 GB RAM by running only one processor, so individually you should have 8 GBs for each one of them. Got it? Yes. So the RAM requirement will be really more, and if one processor fails, then it will affect speed. So assume that here we bought 4 processors, right? And you bought 4 different devices. So at that time, these 4 guys will be working together and these 4 guys will be working individually. So if this guy has been damaged, this whole process will slow down, right? So that is a small disadvantage, right? Yes. So now you got some basic idea at least with respect to these 3 types, right? So we discussed about multiprocessing, multitasking, multiprogramming, multitasking, multiprocessing. So these are the 3 types which we have discussed in this particular lecture, guys. Got it? Yes. So these topics are really interesting, right? Yes. So in the next lecture, we'll be discussing about the last 2 types, I think. So yeah, the last 2 types, that is a real-time operating system and the distributed operating system. Okay? Yes. So in the next lecture, let us meet and discuss about real-time operating system and distributed operating system. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.